let's define our joke. Let's define the data structure of our joke. We already defined it here in text format. What are we going to use for representing our jokes? What do you say? And now, what?
A record.
A record. Okay, yes, we could do a record. You have to understand that we have two different data structures here. One data structure is the data structure that we internally use to store our jokes. This data structure contains the ID. But the second data structure is the data structure that we use in order to receive jokes. Because that will be a data structure that does not contain an ID, right? Makes sense? Okay? Good. Now I ask again, and now a little bit more specific. What are we going to use for persisting our jokes? For storing the jokes internally, not for communicating with the outside world. Would you still say a record?
Yes.
Yes. Okay, that is possible, but I have to tell you something about records. Records are new for you. Records are immutable. What does that mean? If you create a record, you can never change it once you have created it. So it would be pretty hard to implement something like put. Understand what I mean?
Yes.
That is kind of not so convenient, right? So for internal storage purposes, also when we use entity framework and databases and so on, today, as of today in C#, we frequently use classes. Regular classes as you are used to it. Only for the so-called data transfer objects, for the data structures that you use for your API, you often use records. So records are very well suited for DTOs, data transfer objects. You can use them for persisting your data too, but yeah, in most cases, at least nowadays, you use classes. So let's do exactly that. Let's set up the class. This will be our joke class. Here we are. And it will have a bunch of parameters. The first one is the ID. Let me show you a quick trick here. You can say prop and press tab, and it will immediately create a property for you. Saw it? Then you can say just tab and say ID, something like this. You can also write it with 2 uppercase letters. I really don't care. Whatever you prefer. ID. The next one, prop tab, is a string joke text. I did a mistake here. This should be joke, not joke text. Now it's good. And last one, prop, is the fun level. If we just have values between 0 and 5, we could really go for a byte. That's enough space to store the joke level. The only thing that we have to think about now, and this is a warning in C#, similar to what you are used to in Angular, is that C# is telling us, hey Rainer, you told me that joke text is a string, but you didn't give me a default value, so it might be null. That is not a good idea. So we now have 2 possibilities. Either we say string question mark, that would say the joke might have a text or not. And if we absolutely always want to have a text for the joke, we need to specify a default value here. For instance, we could simply say empty string. The default text for the joke is an empty string. That's not null. That's an empty string. So one of the 2 things you should do. If the property can be null, use the question mark. If the property can't be null, use the initializer, as you've seen it here. Got it? Makes sense? Yep. And these things are gettable and settable. So they are not immutable, they are mutable. Very nice. Any questions so far? Something unusual here? Not really, right? Good. Looks a little bit different from TypeScript. TypeScript properties work a little bit different like this here, but I think this is rather easy to understand, so I think we are good. So for now, I'm going to fold this one up, so I don't need to bother with the details, and I can focus on my code. Next, where should we store the jokes? As I told you, for now, we don't have a database yet. So in which data structure, what would you suggest? In which data structure should we store the list of our jokes? Question.
List.
A list would be an option. Any other suggestions?
Map.
A map. A map is called in C# a dictionary. Okay, that is just a name in C#, but it's essentially the same. A map or hash map or dictionary, it's very similar. What would be the key in the dictionary?
The ID.
The ID. What would be the value in the dictionary?
The joke.
The joke. Exactly. That is another option. Both options are valid. Well, they are not, to be honest, but we'll discuss that in a second. Any other questions? Any other suggestions? I'm sorry. List or dictionary? What about an array? Could we use an array like in JavaScript? No, we can't. Because arrays in C# cannot grow. You have to specify the size of the array at the very beginning, and we don't know how many dad jokes we know. So therefore, it has to be a data structure that can grow. That's a big difference between JavaScript and C#. You have to become used to C# again, and in C# arrays cannot grow. That's different from arrays in JavaScript. Any other suggestions where you would say, okay, we could use this data structure? Good. So I would say let's go for the dictionary. But the list is not wrong. List is absolutely fine. You could definitely use a list too. But let's go for the dictionary for now. But we have a big, big problem with dictionary. Let me show you what I mean. Let's look for it. You can just take a look here. You don't have to follow along. Let's take a look at the C# dictionary here. Oh, that's not the documentation. This is the documentation. And if we go down here, there is a chapter which is called Thread Safety. Please take a look at what's written here. I'll read it for you out loud. A dictionary can support multiple readers concurrently as long as the collection is not modified. Even so, enumerating through a collection is intrinsically not a thread-safe procedure. Why is this relevant when writing a web API? That's a tough one. That's a tough one. Let's discuss that for a second, okay? Let's get rid of that one, let's get rid of that one, and let's draw a little bit. Right. Imagine that this is your web server. Okay, this is my ASP.NET Core web server. This is our web server. Now here, up there, we have a web client, and this web client sends an HTTP request. Let's note it here. HTTP request sends an HTTP request to our server. What happens in the server? Will the system magically start a new process to handle the web request? No, the web server is the process. What is going to be used to handle the web request? You heard the word thread. What is a thread? I think you learned it in the second class, right? Something like this, yeah?
Some asynchronous process.
It's not really a process. Can you describe the most important differences between threads and processes? There are some unique properties there. Can one process access the memory of another process? Nope. Exactly. What if you have two processes running on your computer, let's say Word and Excel, and one of them crashes? Excel crashes because of a bug. Will Word die too? No. Exactly. What about threads? Can one thread access memory of the other thread in the same process? Absolutely. What if one thread generates a, let's say, Stack Overflow exception? Will the other thread in the same process die? Yes, it will, because the entire process dies. These are just two examples of very important differences between processes and threads. So yes, it is for asynchronous and parallel programming. We have multiple threads inside of a process, but processes really isolate applications, while threads work together in a single process to do things asynchronously or in parallel. Got it? And this is the important thing that you have to remember. The web server will use a thread. Oh, okay. We'll use a thread to work through your web request. And once it is done, this is time, okay? Time is flowing from top to bottom. And once it is done, it will send back the response to the client, okay? Good. Now, what happens if we have different color here, a second client that sends a web request at the same time, or nearly at the same time? You have a super popular web server. You are serving the cutest cat videos on earth on this web server, and everybody wants to take a look at these cat videos. So you get millions of concurrent requests. They appear on your network really nearly at the same time, or even at the same time if you have enough network bandwidth. So what's going to happen? Is the web server going to process one cat video request after the other? It depends. If your web server has a single CPU core, it must process the requests one after each other, because we only have a single CPU, and a single CPU cannot do multiple things at the same time. Okay? But what happens if we have multiple CPUs? If we have multiple CPUs, this will happen. Multiple threads. You don't do multi-threaded programming on your own, but it happens behind the scenes. It's just there. Multi-threaded programming is a thing when you do web API development. And what have we just read about the dictionary stuff here? We have read that it is not thread safe. That means that we have a huge problem. If we use a list, or if you use a dictionary, or something like this, our web server can handle a single user. That's not very satisfying, is it? It will continuously crash, and you have no idea why. Even worse, you will test your API, everything will work great on your computer because you are alone. And then you put this application on a web server, on a real web server, and you do your first presentation, and the customer is trying your API, and everything crashes. Why? Because you get concurrent requests. Always keep in mind, web requests are handled in parallel. So whatever you do, you have to do thread-safe programming. I see you already like API development, right? Yeah, it's a challenge, but it's a really interesting challenge to have. Luckily, C# has a solution for that. Of course. You suggested a dictionary. So, for instance, we could have said var joke dict, something like this, equals to new dictionary of, and you said int and joke, something like this, correct? This was your suggestion. Did I interpret it correctly? Yes?
Yes.
And now we know that this is not thread safe, but guess what? There is a concurrent dictionary here. All you need to do is you add to use the light bulb, just as in Angular, using system collections concurrent. See? There is a concurrent dictionary. And now let's take a look at the C# concurrent dictionary. Let's take a look at the documentation. Let's take a look at the thread safety. And take a look at that one. Isn't that convenient? All public and protected members of concurrent dictionary are thread safe. That's exactly what we want to have, right? So we now have a dictionary but it is thread safe. You must remember that. That will definitely be a question in some exams. I will definitely ask you, is it a good idea to use a list or a dictionary in a web application to store some data in memory? And your answer should obviously be no. What you could have done is you could have used the dictionary and used manual locking on top. You have learned about semaphores and things like that in classes before, right? But that's just a pain in the you-know-where. It's so easy to mess up. It's so complicated to program. So forget about it. Just use concurrent dictionary and you're good. Very nice. Now we have a concurrent dictionary. Awesome. By having the concurrent dictionary, we can try here to implement the jokes here. Will that be difficult? Well, let's see. Instead of throw new not implemented exception, we can simply say joke dict dot something like values. That will give me the values without the keys. And that is our list of jokes. And believe it or not, we are done with this method. It's done. It works. Let's try it. Let's run it. And let's check whether we get back some jokes. /jokes. And yes. I mean, it's not a very impressive list of jokes. It's currently empty. But I am happy with an empty list of jokes. That's essentially my knowledge of jokes. I'm not a good joke teller, not at all. I would love to be one, but no, I can't do that. So I'm not going to embarrass myself with telling bad jokes. We will look it up. Maybe we'll ask ChatGPT, right? Let's ask ChatGPT for a dad joke, something like this. Does anybody have questions? Was it clear? Remember, concurrent dictionary. Let's think about the next one. How can we return a joke with a given ID? What do you think? Where would you look for a proper method or something like this? Well, obviously, we start with a joke dictionary. And could we simply say ID, something like this? Sorry. Of course, we need to inject the path parameter. Could we do that? Could we do that? Would it make sense? Of course, why not, right? Let's give it a try. Let's run it. It will fail. Don't get me wrong. But we want to see how it fails. So let's say here /jokes/99. And you see, if I go back here, we have an exception. Key not found exception. If I press continue, we will see a very ugly exception. See? Key 99 was not present in the dictionary. Do we want to have that? No. What do we want to return if the user is looking for a joke that we have no knowledge about? Yes? Not found. Exactly. Exactly. So this implementation needs to be a little bit more elaborate. Let's think about it, okay? So what I'm going to do is I'm going to use here a curly brace in order to have a little bit more space to implement it. And I'm going to show you what we can do. We can say if joke dict try get value, this one. Then we can specify the ID that we got and the out joke. If this works here, then we can say return O results okay joke. Out joke question mark. It should be like that because there might be not a joke. Of course, because it's called try get value. If the try get value returned false, that means I don't have a joke like that. And you said we want to return what? Say it again. Not found. So return results dot not found. Now this looks nice. I personally write things like that a little bit different. I put them in something like this. So I write it in a single line because it's kind of easier for me to read. If try get value return okay, otherwise result not found. But if you would like to split it up into multiple lines, that's perfectly fine. Choose yourself. Now we can try it again, right? Let's run it. Let's try to access the joke 99 again, and it will tell us, see, 404, not found. This is exactly what we want to have. It works like a charm.
You used joke instead of jokes.
Where?
On the request. In the URL.
In the browser.
I'm sorry. Thank you for pointing that out. I made a mistake, but the result should still be the same. Jokes. See? Still the same. But thank you for pointing that out. I made a mistake. So now, jokes, not plural. I used the singular before. Sorry for that. So I give you a second to catch up and try that on your own. Nice. So it works on everybody's PC, so we can try to implement the next one. The map post. Now give me an idea. What do we have to do in order to go about implementing the map post for jokes? So adding new jokes. What do we have to do? The first thing is we need a DTO, a data transfer object. Because we cannot use the class joke here. Why? Because the class joke contains the ID. And we said we want to implement the ID on the server side. The client will not tell us that this is the joke with the ID 1 and 2 and 3, but this 1, 2, 3 will be generated on the server side. So we need a data transfer object for creating jokes. Let's do that. Let's simply add here at the end a record, because for DTOs, we learned that it is a good idea to create records. We say this is a create joke DTO. DTO stands for, again, data transfer object. Here we have the string, which is the joke text, and we have int fun level. Yes, there is partly duplicated code here between the internal class and the DTO. That sounds worse than it is, because in real-world projects, the DTOs partly drastically differ from your internal persistence model. If you really have a super trivial API where your persistence model is identical to the DTOs, you can forget about the DTOs and return the persistence model directly. But typically you have DTOs for the API and then a separated persistence model. Okay. We will need that for Entity Framework 2. Good. So now we can use exactly that DTO for implementing this method. So we simply ask the user, give me a create joke DTO. Let's say this is the new joke. And then let's implement this thing. What do we have to do? We have to create a new ID for the new joke, convert the DTO to the persistence model joke. So we have a create joke DTO to joke, add joke to dictionary. These are the 3 steps that we need to do. Last but not least, return which status code? Yeah.
Okay.
Huh?
Okay.
That would be 200. It would be kind of okay, but not perfect.
201.
That is what?
Created.
Created. Yeah, there is a specific status code for when you created something, return created 201. Returning 200 is not too bad, but returning 201 is simply perfect. Yeah? So let's let's return a create. So first, help me. How can we create a new ID for the new joke? We just want to increment something. It's perfectly fine if we have the limit of 2 billion jokes, because that's the upper maximum limit of integer. So we can simply increment, and we don't care about when we run out of integers. We ignore that. So what we could do is we could, for instance, have a variable up here that is the next joke ID. Let's start with 0, and then simply create a new ID for the new joke. How do I do that? That shouldn't be too complicated. So we have a new request. We want to have a new ID. How do I do that? I want to increment next joke ID. How do I do that? Yeah. How do I do that in C#?
Next joke ID plus plus.
Next joke ID plus plus? No. What's the problem? Threads. Threads. Is plus plus a thread safe operation? No. See? That is exactly what I want you to remember. Can you remember the picture that I have drawn, that I drew a few moments ago? With multiple threads. The problem is that next joke ID plus plus is not an atomic operation. It could theoretically happen that 2 requests come in at exactly the same point in time. They reach 2 different CPU cores. And how does a plus plus operation really work? It reads data from somewhere, increments it, and writes it back to memory. If we have 2 threads, they both read, both increment, and both write back to memory, but unfortunately to the same memory address. And then we have a problem. Then we have the same ID twice. So how can we solve that? We have to learn how to do multi-threaded programming, and luckily C# does all the heavy lifting for us. We can say interlocked.increment ref next joke ID. And that is exactly what you should use. That thing is thread safe. So you see, we started very simple, but now you see where the problems are. Luckily, if you have a database later in this semester, if you just use a SQL database or a MySQL database or a Postgres database, you don't have to worry about that, because the database will do the serialization for you. But for now, this is definitely a thing. So now we incremented next joke ID in a thread-safe way. By the way, what you said was perfectly okay in a non-multi-threaded environment. So it wasn't that bad, but yeah. I let you run into this trap consciously. So next we convert the DTO into the persistence model. So we can say var joke to add is a new joke. And here we specify the different parameters. So we say we have, what do we have? We have the ID, which is the next joke ID. This one. Oh, sorry, I forgot something. The interlock increment, of course, it returns the next one. Var new ID. This is correct. Here it is. Sorry, forgot it. Then the next one is we have the joke text, which comes from the new joke and is the joke text. And we have the fun level, which is the new joke, new joke, and the fun level. I did something wrong. Yes, here, this should be byte. Sorry, I mixed up the data types. Now it's correct. Understand what I do? I take the DTO, which we get as the input parameter for the API, and I convert it into a joke, because that is how I store jokes internally. The comma, you mean?
The comma, sorry.
Yeah, okay, very good question. The comma is there because I can immediately, if I want to add new properties, I can immediately start writing new properties, and I don't have to go up in the next line and add the comma again. So it's usual, or it's considered good coding style in C# to always append the comma at the end. So if somebody wants to add something additional, they don't have to go up one line, add the comma, and move down again. So for instance, if I have multiple properties and I want to simply copy this line, I say check, 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 and I have new properties and I can fix them and it's okay. I don't need to worry about the commas. But it's perfectly fine. It's absolutely no problem. If you dislike this comma, just remove it. C# is happy with both types. There are programming languages which demand the trailing comma, but not C#. C# offers you the choice. Good question. So now we can add the joke to the dictionary. That shouldn't be too complicated. It's the joke dict dot add or update, or try add. In our case, we can say add or update. That is not a problem because we absolutely know that there is no joke with this ID because we just created a new ID. So it's perfectly safe to say new ID here and the joke to add. And that should add no, sorry, I had it wrong in my mind. We need to do try add. But we can ignore the return value. Why? Because we know that this is a new ID. This operation shouldn't go wrong. You know what? Let's use that as a very good example for returning an internal server error. We could say if not, try add. If it didn't work, we could say return results status code HTTP, no, it's called status codes internal server error. This is how we can return an internal server error. This should really, really never happen. So therefore, we can really say it's an internal server error. Something really bad has happened. We can even add a comment which says this should never happen. And last but not least, we return created. Return results created. Now here we have to return two things. First, we have to specify where the new record can be found. So we can say here jokes slash new ID tells the caller, hey, you just created a joke. If you want to read it later on, here you can find it. And the second thing that we return, and now you have to listen closely, is the joke to add. Why for sake are we going to send back the joke that we just received from the client? Why? Isn't that duplicated code unnecessary communication? Yeah?
I mean, the joke to add has an ID.
Exactly, that's the point. The server might have changed the data before adding it to its store. Adding an ID, for instance. It could also do different things. It could maybe clean up the text by removing trailing blanks or something like this. So this is the usual way of writing an add operation for an API. We receive the DTO and we respond with the final data that we store to the database. This is what you should remember. And this is now a very good example for such a creation operation. We generate a new primary key, we transfer the DTO into the persistence model, we try to add the data to the database, or in this case our dictionary, and finally we respond with created, where we tell the client what we really inserted. Let's give it a try, right? Here you are that joke.
Why did the tomato turn red? Because it's all a salad dressing.
Perfect. Let's take this one, okay? So let's do a post. It is the URL is, let me see here. This is the URL. Jokes. Remember, content type, we discussed it yesterday, is JSON. Then you must use a space if you are using the REST client. If you use Postman, you don't need that. Now the joke text is exactly what we had up here. And what would you say about the fun level? 0, 1, 2, 3, 4, 5? Let's give it a 4. You can choose your own fun level, right? And let's see what's going to happen if we send this to our API. Very nice. You see, first, our joke has now the ID 1. So it worked. We got a new ID. Everything was stored. That looks good. We create back 201 created. And the server tells us that this joke is now available at the URL /jokes/1. That's not perfect. There are, in real world, I will make it a little bit differently, but I think it's okay. And finally, before we go into the break, so that we have our success moment, we can now get a list of jokes, and now we get back not an empty list of jokes, but we already get back a list of jokes, and we can even select the specific joke, and you see it works. So we can now add new hilarious dad jokes, we can get a single joke by ID, and we can retrieve a list of all the jokes. Awesome. So in the next hour, we can do updating of jokes, and we can do deleting of jokes. Let's do a break.